Welcome back, kids and coaches, and today we're going to be covering the first part of our gait and running analysis. So we will be focusing primarily on the walking part of the gait cycle today. So what I'll be doing is I'm going to be going over the basics behind that, and then I'll show you how to do a couple of the measurements you'll need for the gait lab. So first off, when we talk about gait, we are talking about how the body moves or ambulates. So if you ever see the term ambulate or ambulation or gait, they all mean the same thing. How do you walk? How do you run? How do you propel yourself? So you may also hear the term locomotion would work as well. Now, there's four main terms that you're going to have to be aware of. You have stride. This is when you have the amount of time from, or the overall time you have from, say, one heel hitting the ground to that same heel hitting the ground again. Your stride length is the distance that that single heel covers over that entire step. Meaning, if I take my right foot, so I take a step out and I hit the ground with my right heel, then I take a step with my left foot, and then I take another step with my right foot where that right foot hits, or right heel hits the ground again. That is a full stride length for my right side. The step length is the distance you have between one heel to the other lengthwise. So now if I just took a step out with my right heel, that's where I would have one step. So to give you just a quick little view here, this is my right foot, this is my left foot. If I take my right foot and I step out, that is a step. The step length is the distance between this heel and this heel. So back there. To measure that, I would just take a tape measure and I would place one end where my first heel, my lead heel is, the second end where my back heel is. And this total distance here, and again, you want to make it sure it's a straight line, that is what my step length would be. In this case, my step length would be about 44 centimeters. If I had a stride would mean that I start, again, this here being my left foot, this being my right foot. My right heel is on the ground. I step out with my left heel, and then I step forward again with my right heel. The distance between where my right heel was, which is back here, to where it is now, that is a stride length. So the way I measure that is if I start back at the beginning here, I would want to mark off where that right heel is. So I just mark, put a little tab there where that's at. So actually, let me just turn that around so you can just kind of see that for a little contrast. All right, so you could just see the tab of paper there. And this is where my right side starts. So I'm measuring the stride length of my right side here. Now your stride length should be pretty equal, but it could be just slightly off. Either way, you would want to measure to get your best ideal stride length if you measure both legs. But really, in all practicality, unless you have something really wrong with you, especially like if you have a length discrepancy, something like that, you only really need to measure one side. So I take my left foot and I step forward, and then I take my right foot and I step forward again. Now I'll go ahead and mark off where that right heel ended up. So I am marking it so that the top of this postcard here is at the back of my right heel. When I first started, the top of the postcard was where my back heel was. So to measure this, I am going to take my tape measure and I go from the top of the first one to the top of the second one. And when I go to get that here, I'm showing a stride length of 42 centimeters. Now, your stride length will always be greater than your step length. I realize that in this example, I didn't have a longer stride length than a step length, but it was just to show you how to actually measure it. So I will be demonstrating this standing up and doing it so you have a lot more clarity to it. Now your step width is just the distance you have between your heels after a step. So if I take a step, what I would want to do is, again, I want to mark off where each of my heels are. So I'm going to mark this one here. And how I'm going to mark this is I'm going to put the side of that postcard so it is right roughly in the middle of my heel. You want to just really look from where your Achilles tendon is and go straight down from there. And then I have my back heel, and again, I'm going to mark it so that the side of this is right in alignment with that. Okay, so I have my two measuring points here, and now I'm just going to measure from this side to this side. Let's move these forward for you so you can get a better picture here. Okay. And for this, I got about 14 centimeters. So normal 7 to 9, but granted, I'm just kind of piecing this together for you. So most likely my actual measurement was a little bit off there. But now at least you have a decent idea of what these two look like. And I'll go over this again here at the end here. Now, you measure gait in terms, well, not really measure gait, but you measure your overall walking pace or walking speed in two categories: cadence and velocity. There are only two ways you can increase your speed, and this is walking, running, anything. You either increase your stride length or you increase your stride frequency. So velocity is our measurement of speed over time. The way that we measure this in terms of a gait analysis is in meters per minute. Another useful measurement is meters per second. This is especially useful when you talk about, say, walking across, like, say, an intersection. So, for example, here in North Phoenix, several intersections cover roughly 8 to 10 lanes worth of traffic. Knowing what the speed you need to be able to walking at to get across that lane or get across the whole street is important, because it'll tell you if during a typical traffic stop where you get the walking or crossing signal as a pedestrian, do you walk fast enough to make it across that street given the time that it allows you? Typically, you want to be at about 1.2 meters per second to be able to make it across that traffic lane during your walking time. Now, your cadence, you can also call your step frequency or your stride frequency, but this is just how many steps you take per minute. So when you talk about cadence, it is now how often each foot hits the ground in a minute. So if I start here, and these are both my feet, that's 1 step, that's 2 steps, that's 3 steps. So each time your foot moves, that is 1 step. Each time you stride, that is 2 steps. So let's start with my right hand here. Step, step, step. My right foot or my right hand has hit the ground now 1, 2 times. Okay. On that second time, that is a full stride. Now, you have a total of 8 phases of gait. As I mentioned in your assignment page here, when you look at, oops, and that's not the right one. Here we go. When you look at the homework for gait, it'll tell you to only use 7 periods or 7 cycles. And like I was saying, this first one here is not counted. So in your homework, it'll say 7 gait phases. The one that it is not counting is this first one here, this initial contact. So your first one will be your loading, and then your last will be your terminal swing. So you see how your terminal swing and your initial contact are really just kind of the same thing. If you start with your feet both on the ground, you're already starting in that loading response phase. So there is no landing. You're not landing on your heels when you first start. You're starting at that loading response phase. So when you do your assignment for gait, make sure you do not include the initial contact into the homework. If you notice, all of these phases dictate where your foot is relative to the ground. These first 5 here, your foot is in contact with the ground. Your last 3, your foot is off the ground. If you see the term swing, not counting pre-swing, pre means before swing, but when you're at your initial swing, mid-swing, terminal swing, swing equals off the ground. Because to swing your leg means you have to move it back to forward. You cannot move, I mean you can, but you'll be dragging it, but you can't move your leg efficiently if you keep your foot on the ground. You have to lift it in the air to swing it forward. So swing means your foot is off the ground. Stance means your foot is on the ground. Your stance phase of gait, so when your foot is on the ground, makes up nearly 2/3 of the gait cycle. When you're in the swing, it's only about 1/3. So you only spend about 1/3 of your gait cycle on the ground, or I'm sorry, off the ground. Now, when we go through the full gait cycle here, the first thing to note is that the only differences we have between running and walking, aside from the speed and the length of, like, say, your stride, is that everything's exactly the same, except when you get to, I'll show it on this one, but when you get to this phase here in the terminal stance and pre-swing, both feet are off the ground. So the only time that running and walking differ is that running has a period of flight, meaning both feet are off the ground. Your definition of walking is that at least one foot always maintains contact with the ground. A typical walking pace, so an average walking pace for most adults, is about 3 miles an hour. So that is your typical walking pace. While there are some exceptions, like if you're a world-class speed walker, you can go faster. But in general, average speed to differentiate running from walking is about 5 miles an hour. About 5 miles an hour is the amount of speed you have to achieve to get both feet off the ground at once. As soon as both feet are off the ground at the same time, you achieve that period of flight, you are now running. As long as you always have one foot on the ground, you are walking, no matter what the speed. Now, I'll let you all go through the different single stages of gait because I want to get into actually showing you how this is going to work. Last kind of things to note is your total range of motion in the sagittal plane. Now, when we talk about gait anomalies, we're going to get into that on Wednesday, but gait anomalies will tell you different things like how far off you go side to side, where your stride isn't correct, if you swing out, if you swing around. So when you look at normal range of motion of gait, you are only talking about the lower extremity, and you're only talking about the lower extremity going through the sagittal plane. So forward, backward. This means you are only dealing with flexion or extension movements. There should be no abduction. There should be no rotation. There should be no horizontal abduction, nothing like that. It should be straight in a line in the sagittal plane. Sorry, I misspelled that there. Okay, so for the hip, you have a total of 50 degrees range of motion. You have 40 degrees when you have your initial contact. So 40 degrees means that you are lifting to get into that initial contact phase. So when my foot first touches the ground, let me try to get you a little better angle here. All right, so when my foot first touches the ground, my hip flexes out to about 40 degrees. So from straight down here to where it is there, that's about 40 degrees. When I get into that pre-swing phase, so pre-swing will be where my foot is about to leave the ground. Now I get into about 10 degrees of hip extension. So if this were straight down, my hip extends about 10 degrees. So your hip really only moves about 50 degrees during the average gait cycle. Now, if I'm running, of course, my hip is going to flex a lot higher and I'm going to extend a lot farther. But with just the walking phase, or the walking style of gait, only about 50 degrees. The knee is going to have about 60 total degrees range of motion. When I bend my knee, all right. So when I hit this loading phase, where I am hitting my heel to the ground, my knee, if you notice, only is slightly bent. Only about 20 degrees that will bend. If I go from my initial contact all the way through to mid-swing, which comes forward, my knee, so initial contact right here, and then down and forward to mid-swing. Now, my knee will get a total of about 60 degrees of flexion there. When I look at my ankle, terminal stance is this. Sorry, terminal stance is where I am just about to touch the ground. When I'm just about to touch the ground, I am in dorsiflexion. So I'm going to have, if this is a flat foot, at terminal stance, right where I'm about to touch the ground, where my heel will strike first, I'm at about 10 degrees of dorsiflexion. When I get to my initial swing, so my initial swing is from here to pushing off, I'm in about 20 degrees of plantar flexion. Now, the only transverse plane movement you should have is when the pelvis rotates. And I'll show you some more examples of this on Wednesday when we get into that. But your transverse plane movement is only really going to be pelvic rotation, meaning that when I walk or run, I take a step forward and I have to rotate my hips. Now, I'm over-exaggerating this here, but you do this so that you maintain proper balance. It's also why you walk with your arms, and you walk with your arms opposite of your feet. If you ever notice when you're walking, if you step forward with your right foot, you step forward with your left hand. And that's because you have opposites. Now it keeps my center of gravity still in the center of my body. I'm not going to be swaying one way or the other. And really, if you try to walk where you step with your right side and with your right hand, and then step with your left side and left hand, and see how well that works for you, because it really is very difficult to do. All right, here are all your muscles that are going to be active during gait. So this will help you a whole lot with your homework here. All right, so what I want to finish up with for this one is just showing you how the full gait process looks and then how we can actually measure that. So I am going to real quick switch my headset here for you. All right. All right, there we go. So hopefully you can all hear me. We'll just do a real quick test to make sure. And can I hear myself? Yes, perfect. All right, so let's look at our different portions here of the actual gait that we'd be doing to help give us these different spatial characteristics. So again, we are going to be looking at stride length, and step width. Easiest thing for you to use is going to be really just a tape measure. So this will help the most out of anything for you. And I'm going to flip myself around here so that I can give you a little better perspective. Okay, if I'm starting just here and I take a single step, that distance I have from my left leg, so specifically from the heel of my left leg, all the way to the heel of my right leg
or my right foot, I should say, that is my step length. Okay. So I'll take, and I'm going to just mark it off with these business cards here. But I'm going to start out by having my left foot marked there. So my left foot is marked. And then I'm going to take a full step out, what I would consider a full step for myself. And I'm going to mark that right there. And that would be my step length. To then measure that, let's see if I can keep this so you can see everything. And close enough. But I'm going to go from the back of this card here to the front of the other card there, because that is where each of my heel placements were. When I measure that off, now I am getting a measurement here of just about 53 centimeters. Your stride length and your step length will both really depend on how tall you are, but more specifically, how long your legs are. So someone that has extremely long legs are going to have a greater step length, greater stride length than what you normally would. So for myself, granted, that was just about 53 centimeters, so I'm still probably a little bit short there. But anyway, your stride length then is going to be the measure of when one heel, so I'm measuring my right heel, so marking it off there, starting here, okay, so just starting shoulder width. I want to know when that right heel hits the ground again. So I take a step forward with my left foot and a step forward with my right foot, and I will mark off where that right foot is. Now I am just going to measure the distance I have between these 2 points here. And if I do that real quick, so you can see I have the tape measure going from, oops, actually that should be up there. So I want to go from the front of the card on my lead foot, and I want to go to the front of the card on my back foot. And for myself, right about here, you can see I'm at roughly 94 centimeters. Now again, just taking some steps, like with a single step, most likely you're going to be a little bit short. To get your true gait, you would want to be taking, say, so to get my true gait measurements, I would want to measure myself as I am casually just walking, because that'll give me what my true step is as opposed to what I'm just trying to do with the standalone measurement. But this at least gives you the idea of how to measure that. Roughly, your stride length should be about twice the size or twice the length of your step length. So if my stride length goes from here to here, that should be about twice as big as when I step from here to here, roughly. So that there is your step length and your stride length. Now, stride width. This just goes, now don't measure yourself from this initial stance here. So that initial stance is not going to give you an accurate representation of what your actual stride width is. What I want to do is I want to take a step and again, I'm going to mark off where each of my feet are. So I'm going to mark right where my Achilles tendon is roughly. So I want to be roughly right in the middle there, and I place that marker there. And then I'll do the same thing on the back foot, placing that marker there. So right in the middle, roughly, with that. And now you see I have these 2 points. My step width, or my stride width, the distance I have from this side here over to that side there. Now I'm just going to move this back so that it is just about equal for you there, so you can just see where that's at. So granted, this isn't going to be, again, the most perfect measurement, but at least gives you an idea of where I'm at. And for myself here, that'll come into focus a little better. You can see I am at roughly about 16 centimeters there. So that's giving you that. The wider set your legs are, the bigger, or the wider set your hips are, the bigger you'll be with that, or the wider that will be. And then last thing I want to show you here is how to measure your velocity and your cadence. So velocity is going to be distance over time. To measure velocity, what I want to do is I want to mark off my starting point. So I'm going to start right here. And I would start a stopwatch. Okay, so all I would be doing is going with a stopwatch here, and I would go for a certain amount of time. Depending on how big of an area you have, I would suggest you do either 5 seconds, 10 seconds, or 15 seconds of walking to get a true velocity, or to get at least a good estimate of your velocity. Because what I'm going to do is I'm going to start that timer and I'm going to walk. Okay. And let's say that this was 5 seconds and I made it all the way to here. Okay. So I would put that here. Actually, take that back. I'm going to put that up here because that's going to be my total distance. All right. So from right here where I ended to back there where I started, that's the total distance I covered. Okay. Now, all I would have to do is measure, and granted, my tape measure isn't going to be that long, but I would just measure from where the end point is of that one all the way to where the starting point was back there. So let's say, for example, that I covered about 10 meters. And I did that in, we'll say, 5 seconds. If I want to get velocity, I want to get velocity in meters per minute. So if I did 10 meters in 5 seconds, I would want to multiply this out by 12. So 60 seconds divided by 5 equals 12. I would multiply this here by 12. So 10 times 12 equals 120 meters per minute. So if I walked 10 meters in 5 seconds, that would mean I would be walking at a velocity of 120 meters per minute. Remember, it's velocity and not speed. Speed is a scalar unit. So you would only be measuring speed if you started and ended at the exact same place. Velocity is distance over time, meaning, or I'm sorry, displacement over time. So you have to end somewhere else other than where you began. That would be how I get velocity. If I did 10 seconds, if I did 10 meters in 10 seconds, now I would divide 60 seconds by 10, which would equal 6. I would multiply my 10 meters that I covered times 6, because I would be able to do 6 cycles of that in a minute. And that would give me a total velocity of 60 meters per minute. If you want to take that number and make it into meters per second, you divide that number by 60. So if I had 60 meters per minute, and then I divide that by 60 seconds per minute, that equals 1 meter per second. And that is just how I get my total velocity. To get my cadence, I take the number of steps I do in a given time period. So for cadence, I don't care about speed, although I still want to be walking at my normal walking pace. I don't want to try to, go too fast, too slow. Again, just count how many steps it takes you to walk in a given period of time. So if I do 5 seconds and so in 5 seconds, I take, let's say, 7 steps, my cadence is then going to be 7 steps times 12, because 5 seconds is 1/5 of a minute. If you took 60 seconds divided by 5, it equals 12. So I multiply my steps that I took in 5 seconds by 12, and that would equal a cadence of 12, 84 steps per minute. If in 10 seconds, I take 12 steps, I multiply 12 steps times 6, because 10 is 1/6 of a minute. So you would multiply by 6, and that would equal then 72 steps per minute. If I go to 15, so in 15 seconds, I take, let's say, 20 steps. And I'm just throwing out random numbers here, so there's no pattern or anything. I would take then 20 steps times 4, because 15 seconds is 1/4 of a minute. So 15 seconds 30 seconds, 45 seconds, 60 seconds, 4, multiply that by 4, now it would equal 80 steps per minute. So that there is just how you would calculate velocity and cadence. So that is everything new I have for you guys here for today. When we come back on Wednesday, we will be getting into more of the actual, say, anomalies that happen with your gait. So different improper or different gait patterns that have different problems associated with them. And we'll talk about running as well and the different kinds of running that you can do. And then we will move on from there. So thank you all for getting through that with me, and I will see you all on Wednesday.